Hi, this is our final capstone presentation. Our project name is Just Flow. My name is Anthony.
My name's Luke,
My name's Ben.
and this is GMF Dev.
The problem that we chose to solve was creating a good playlist is a time-consuming task. Now this breaks down into two sub-problems.
Finding songs to match your interest.
Creating an ideal order of the playlist.
From this problem, we identified two use cases that we thought would solve the problem. The first use case is optimally ordering a playlist for the best listening experience of the user. The second use case is, given a single song by the user, generate a playlist of similar songs.
So, now that you know a little bit about what our use cases are, I'm going to be going into a little bit of depth on what is actually happening behind the scenes. Now, in our playlist generation, we're using the k-nearest neighbors algorithm to find the songs which are most similar to the inputted seed song. Now, a major reason why we wanted to use this approach is because it was unsupervised. This allows us to use unlabeled data to create results. Another pro was that we could easily change the feature set in which we're using. This allowed us to test different varieties of feature sets and allowed us to compare those results. Now, the cons are it's very slow based on the size of the feature set. So we're using a very large feature set, which in turn makes this algorithm run a little bit slow. There's also no learning, so basically what this means is for every seed song which you input to make a playlist, the same playlist will be outputted. Our second use case which we were focusing on was playlist organization. Now, within a playlist, there are two main things in which you want to do. Organize the songs which are similar and sort those songs in ascending order. Now, our first algorithm, which is clustering, allows us to group the similar songs. And then our second step in the algorithm is to actually sort those songs based on the tempo. The pros and cons are very similar to playlist generation.
For our application, we decided to integrate with the Spotify API to allow our system to be easily incorporated to people's everyday lives, as many of our potential users currently listen to music through Spotify. This screen will appear to the user only on the first time they use the application. It allows the user to grant permission to our application so that it can access their account to generate and order playlists on their behalf. So once the user clicks agree, they are taken to the home screen of our application. From here, you can view all of your playlists on your Spotify account. You may also notice the list of playlists on the left menu. By clicking either one of these list items or one of these cards, you can view the playlist in further detail. So on the playlist screen, you can view all of the songs contained in the playlist. You are also able to play the playlist from this view. Once a song is playing, you have full control over your listening experience. You can pause and play the song. You can skip forward a song, as well as skip back a song. And you can adjust the volume of the song. Now, to demonstrate the use cases of Just Flow, you can go to the Generate Playlist item on the left menu. This takes the user to the following screen. Here they can specify the name of the new playlist, the number of songs they would like the playlist to contain, as well as the seed song they would like the playlist to be based off of. The user has the option of previewing what the song sounds like to make sure they're selecting the right song. Once they're satisfied with the song, they can click Generate. Once the system has generated the playlist, it will take the user to the playlist screen. The user can now explore their new playlist. So as you can see, the songs do in fact sound similar. If they would like to optimize their listening experience, they can do so by selecting the Organize button. This uses our ordering algorithm to arrange the songs into an order for optimal listening experience. So now to show off the features again, we can create a new playlist. This time we would like a classical playlist. So we can go through the same workflow. And we can select a classical playlist, a classical song. So as you can see, all of the songs that were selected are also classical. And then we can select Organize to create the playlist in an optimal order.
Now that you've gotten a feel for how our service looks and operates, we will explain the feature set we use for our algorithm. One of the features we use in our feature set is tempo. For those who are unfamiliar, tempo is essentially the speed at which a song plays. This is important in regards to song similarity because two songs that have very different tempos will not sound similar to one another.
Our second critical feature is called the Mel frequency septual coefficient. Now, what the Mel frequency septual coefficient is a small set of features which concisely describe the overall shape of the spectral envelope. This is often used to describe the timbre. The timbre, in simple terms, is what differentiates one musical sound from another.
The third and final feature that we use as part of our feature set is chroma. The chroma is typically a 12-element feature vector where each element in the vector indicates the energy of an individual pitch class, such as C, C sharp, D, D sharp, etc. As you can see from our example, C sharp is strongly represented in the graph.
To evaluate the accuracy of our algorithm, we needed to find a metric that measured song similarity. After extensive research, we found that genre is the best way of doing so. For example, if two songs were labeled of the rock genre, we would assume that these two songs were indeed similar to one another. Now, this is not the best metric. This relies heavily on the third parties who are labeling the songs a certain genre. This can sometimes be subjective and not always accurate. Also, genres tend to be very vague. One genre can hold hundreds of thousands of songs. Now, not all of those songs in that genre will sound similar to one another. Nevertheless, this was the best one we could find.
Now, due to the skepticism of genre being a good metric, we needed to verify that it would be acceptable for our use in JustFlow. To do this, we performed dimensionality reduction on both the MFCC and chroma feature vectors for all of the songs in our database. To do this, we used a nonlinear reduction algorithm known as TSNE. The result, as you can see, showed us that the features did have a strong correlation to the genre, thus indicating genre would be a suitable metric.
After finding a suitable metric to test our use cases, we needed to set up a test suite in order to compare our results. The test suite for playlist generation is the following. We compared two algorithms. The first was solely using the MFCC feature. The second was using a combination of the MFCC, tempo, and chroma vector. For each of these algorithms, the tests were as follows. For each genre, 10 seed songs were selected. With each seed song, a playlist was generated, and the average results based on each genre's representation within these playlists was recorded. The results depicted in the pie graph represent the percent of each genre when the seed song was classical. Some more test results for playlist generation are shown here. What you are seeing is the average percent of songs similar to the seed songs within that playlist. So, for example, if we look at the two algorithms genres for classical, you can see that the first algorithm has a high 90% accuracy and the second algorithm has a high 80% accuracy. Now, there are a few possible causes for the low accuracy which you are seeing in the bar graph. We used a very small data set which greatly limits the amount of songs that our algorithm could choose from. And as we touched on before, genres can be mislabeled and are often too vague.
Here are some results of our playlist organization algorithm. On the screen, you'll see two graphs. The left-hand side graph displays tempos of an unorganized playlist, where index 0 on the x-axis represents the first song in the playlist. As you can see, the playlist starts with a high tempo, then fluctuates greatly throughout the remaining songs in the playlist. This is very unorganized. On the right-hand side, the graph represents the same playlist after being run through our playlist organization algorithm. The algorithm identified two subclusters, and for each of those subclusters, it organized the songs from lowest tempo to highest tempo. Now this is an ideal ordering.
Thank you for your time.
time. I hope you enjoyed Just Flow.
Subscribe, comment, like.
Raise your hands if you have questions.